My name is Dominik Wermke, and I'm a usable security and privacy researcher at the CISPA Helmholtz Center for Information Security in Germany. If you want to follow along with the slides for this talk, you can follow the QR code or click on the link, or visit the link below it on my website. In this talk, I want to present past and ongoing research we conducted in the open source ecosystem. But first, the software supply chain is under attack. Hundreds of US news sites push malware and supply chain attack. Microsoft says nation-state threats and zero-day attacks are increasing. Supply chain hacks are on the rise, but most companies aren't prepared. And NPM malware attack goes unnoticed for a year. So the last one here is especially relevant for this talk because especially developers are a high-value target for such attacks, potentially amplifying any vulnerabilities or introduced malware to thousands of users of their code. And developers also act as a potential weakest link in the supply chain, with many involved individual developers in the code, with many individual setups, as well as many potentially large attack surfaces for each developer. So you might ask, where does research get involved in all of that? As I mentioned, I'm a usable security and privacy researcher, and you are probably familiar with security and privacy research in general. So where does the usable part come in? So security and privacy research enabled many cool security technologies and approaches like public key crypto and end-to-end encryption. But in the past, uptake of these technologies was rather sluggish by end users. An angry researcher, you can tell that they are quite angry about it because of the eyebrows, might blame the users for the slow uptake. But one of the foundation ideas behind the field of usable security and privacy is that the users are not just stupid or lazy, but that we as researchers are responsible for developing or improving current approaches so that they are more usable. So you might ask, but if it's not the user's fault that they struggle with security, who is at fault? And if you look at more or less recent vulnerabilities in code, such as Log4Shell, Heartbleed, or Shellshock, one might assume it might be the developer's fault. I mean, even the bad guys fail. So in these examples where ransomware developers struggled with cryptography. So again, the angry researcher with the idea that now the developers might be at fault. And that's where my specific field comes in, usable security for developers. So similar as for the users, we don't necessarily blame the developers for struggling with security and privacy, and instead hope to support and empower them towards building more secure software. And in today's software ecosystem, because it's quite large, this idea extends to all types of software experts, such as developers, administrators, maintainers, team leads, data protection officers, and so on. So you might ask, why specifically just experts and not like improve security for end users or something like this? Because experts, such as project leads, developers, or maintainers, have a huge impact on the software ecosystem. Specifically, by supporting these impactful experts, we can bring security and privacy improvements to many individual users of their software. So for example, empowering an expert to include a specific security feature in their code could potentially affect tens of their projects, hundreds of lines of code they write, which then get potentially deployed to thousands of times. And then these deployments could be potentially used by millions of end users, which then benefit from this increased security. But being an expert does not necessarily result in them being knowledgeable about security, as recent software vulnerabilities have shown, such as the Log4j vulnerability, which did and still does affect many services. And tech-only approaches like firewalls, password managers, or developer and analysis tools might not be able to solve this problem alone, because in the end, they themselves are dependent on being developed by experts, being deployed by experts, and being correctly used by experts. And for example, the recent and still ongoing kinda LastPass breach originated from credentials and keys stolen from an employee. And even the bleeding edge advances in AI might still lead to vulnerabilities, as a series of papers by NYU showed. This large attack surface of the software supply chain can be especially challenging for open source developers, just because the ecosystem is that large and that well connected. So GitHub State of the October's report from 2020 mentioned that most companies on GitHub rely on some form of open source software in their stack, resulting in widespread usage. And the median number of dependencies in the NPM ecosystem is 683, resulting in a large potential attack surface. So in this talk, I also want to convince you personally of something. That is why you should care about open source and related to that, open source software security. Here's a slide of open source software logos. You are probably aware of some of these logos and maybe even use the tools from time to time. But open source software probably has permeated your life more than you are aware of. Open source code appears as foundation, glue, or during the build processes in many of our software projects. Whether as low-level system drivers and operating systems, as tooling in our daily jobs, or simply as dependencies of our hobby projects. Open source software is an important building block of our everyday software lives. So with this motivation, onto the research part. As I mentioned, I want to talk about 3 research projects in the area of open source, namely Committed to Trust, in which we interviewed maintainers of open source software and which was published at last Oakland, as well as 2 ongoing projects, one about reproducible software builds, and one investigating how industry projects deal with the security and the impacts of using open source components in their projects. So first, for the already published work, Committed to Trust. For this work, we investigated how open source projects handle security and trust behind the scenes. Specifically, we were interested in processes that are not necessarily visible from the code or the repository level. We based our investigation on the following research questions. First, how are open source projects structured behind the scenes? Second, if and what guidance and policies are provided by open source projects? And third, how do open source projects approach security and trust challenges? To answer these questions, we conducted interviews with 27 owners, team leads, maintainers, and contributors of open source projects. We roughly sorted our interview partners into their roles and found that they tend towards the leader or owner side. And we suspect that this might be an effect of being often referred further up the project until we reach the team leader or the owner for the interviews. As for the results, I want to go over them in like 3 sections, namely for trust, security, and processes. So first up, for trust. We asked our participants if their projects had encountered a trust incident by their own definition in the past, and a large majority had not. Mentioned trust incidents included drive-by cryptocurrency miner commits, failed breakdown checks for larger projects associated with companies, and a proactive account block after a stolen laptop. Most of our participants use some form of meritocracy for establishing trust with new contributors, with some even assuming trustworthiness by default to encourage new committers. And the majority of participants never experienced a trust incident in their projects and also did not establish specific trust incident strategies. Larger, likely older projects seem to have more past experience of incidents and often offer more specific strategies. For the security part, we asked our participants if they encountered trust security incidents in the past, and the majority did not. Encountered past security challenges that not necessarily led to an incident included suspicious or low-quality commits, as well as vulnerabilities introduced by dependencies. Overall, only few projects have experienced an outright security incident, and although many of our participants were familiar with suspicious or low-quality commits, as well as potential vulnerabilities introduced by dependencies. Next, we were interested in the guidance and policies provided by the projects in terms of processes. And the most mentioned type of guidance by our participants included general guidance for contributing to the project, programming language-specific guidance such as code styling, and guidance for the project setup or the build infrastructure. A factor for not providing guidance included the required program hours, such as in this example. Overall, our participants appear to diverge in their opinions regarding the helpfulness of written guidance. For security policies, larger projects mentioned dedicated security teams, while smaller projects mentioned a security contact channel. And most projects included some type of disclosure policy or at least contact for security issues. As a quick recap, we found that projects are highly diverse and deployed security measures, trust processes, and motivations. Growing scope and contributors of a project also result in growing needs for the security and trust processes. And smaller projects handle security and trust incidents as they happen and then establish processes at that point only. Oops. So for a currently ongoing research project, we investigated the reproducible build ecosystem closer. And this approach was inspired by the famous Ken Thompson quote, to what extent should one trust a statement that the program is free of Trojan horses? Perhaps it is more important to trust the people who wrote the software. And an important step of trusting the people that wrote the software is, of course, to also be able to trust the resulting artifacts. And reproducible builds are an approach to this problem. So given a public source code and distributed binaries by a vendor, reproducible builds allow any independent party to validate that software artifacts were built from specific source code without any manipulation or change. And ensuring reproducible builds isn't a straightforward task because challenges include stuff like timestamps placed by developers and tools in the code, build specifics such as file orders and build directories, as well as any other randomness in code or build that changes the resulting artifacts. For this research project, we conducted 24 interviews with reproducible build experts, and we investigated their approaches and experiences, as well as identifying potential attractors and detractors to creating reproducible projects. For our preliminary findings, we found the following. We identified a number of themes related to our participants' motivations for making their builds reproducible, with the two most common ones being same input should always compile to same output, and broken expectations in that how a computer should handle or should behave that does not match the reality that our participants wanted to see. For themes related to their experiences, our participants reported generally a positive experience with upstream projects, and they specifically mentioned that the need for patience and good communication with upstream projects. And for common obstacles, participants mentioned most commonly date and other time values in files, as well as build directory names that somewhere get included in the build process. Onto the last project for this talk, open source components in industry projects. So this time, it's basically the other side of the committed to trust paper. This time, more on the consumer side of open source code, namely industry projects. So we wanted to investigate how industry projects deal with the security and trust challenges of including open source components in their software. And we wanted to specifically look at industry projects' processes, decisions, considerations in the context of external open source code. We based our investigation on the following research questions. How are open source components included in companies' tech stacks in terms of position, importance, and effects? What are companies' awareness, experiences, and attitudes regarding the security of including external open source code? And for 3, if and how do stakeholders make decisions and considerations around security and trust challenges of including open source components? To answer these questions, we conducted interviews with 25 developers, software architects, and engineers from industry projects. As for our preliminary findings, I want to highlight the following. We asked our participants if they encountered a security challenge or inconvenience due to an open source component in the past. And almost everyone did. Common examples included no longer maintained projects, breaking updates, and projects delaying or never patching vulnerabilities. We were also interested in what selection criteria our participants use for open source projects. And here are some commonly named ones, namely popularity measures like downloads or GitHub stars, signs of an active or large community, as well as specific features only provided by the projects they select. We were also interested in whether they used internal mirrors or similar setups for their dependencies, or especially their open source dependencies in their projects. And a small majority did. Some further insight tests that we had included that some participants mentioned that their management doesn't seem to fully grasp the benefits and challenges of open source software, while others support utilized open source components by donating, for example, money, developer hours, knowledge, or code. And a few even mentioned following the guidelines of always contribute back to the components they use. As for the takeaways from this work, or should I rather say takeout, because it's a giant ball of spaghetti. So securing the open source software supply chain is somewhat similar to securing a bowl of spaghetti. The chain of the software supply chain, somewhat wrongly, conveys an overall image of linear relations. And with a clear start point, the producers, and often a clear endpoint, like consumers or end users. And it also somewhat implies being like contracts being involved in similar stuff. A better analogy would probably be that of a giant bowl of spaghetti with many intertwined strands, impossible to discern beginning and ends, and even when taking a closer look. And some companies in our study tackled this problem by focusing only on the security aspects on their plate. So for example, by maintaining in-house versions or caches of utilized components, which they then better can vet and test in their setups. So these were the 3 research projects. One already published investigating open source projects behind the scenes, and 2 ongoing works, one with reproducible build experts and one with industry stakeholders using open source components. As for the total takeaways from this talk, 1, or for open source. Open source is not your average supply chain, and projects assuming so might be badly bitten by it. 2, developers might be the weakest link of the software supply chain and can use any support they can get. And 3, I think the best solution for this support is to directly involve the developers in the ongoing research. My name is Dominik Wermke. Thanks for listening to this talk.